Today we would like to present about our project, which is about geothermal. Before we start with the introduce what is geothermal, I would talk about renewable energy. What is renewable energy, right? So I start with introduce my partner, me Shazwani Sairan, and second is Wong Lusam, Izan Shafira, and the last partner is Nurul Fatiha. Okay, what is renewable energy? Renewable energy is energy derived from natural sources that are replenished at a higher rate than they are consumed. Sunlight and wind, for example, are such sources that are constantly being replenished. Renewable energy sources are plentiful and all around. There are many examples for renewable energy source nowadays. For example, one, solars, and then wind, hydroelectric, geothermal, ocean, hydrogen, and the last one is biomass. What good about renewable energy? Generating renewable energy create far lower emission than burning fossil fuel. Transitioning from fossil fuel, which currently account for a lion's share of emissions. To renewable energy is key to addressing the climate crisis. Okay, renewable thermal technologies. Renewable energy source to provide heating and cooling service for space heating and cooling, domestic hot water, process heating, and cooking. Renewable thermal technologies can use a variety of area renewable energy sources that would otherwise be wasted, such as waste energy from industrial process or biomass burning. Renewable thermal technologies vary in the thermal temperatures at which they deliver heating and cooling. Temperature levels are important to define the suitable of different technologies for meeting specific heat requirement in the various end-use sectors. Renewable thermal technologies can range from small domestic application to larger scale application used in industrial process and district heat and cooling network.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Izan Shafira binti Muhammad Taib and my number matrix is 2200172. So for today, I will present about renewable thermal energy. Okay, next is what is geothermal energy? Geothermal energy is heat energy from the earth, geo which is earth, plus thermal heat. Geothermal resources are reservoirs of hot water that exist or are human-made at varying temperature and deep below the Earth's surface. Geothermal technology exploits thermal energy in the Earth interior, stored either in rock, liquid water, or trapped streams. So this is basically how geothermal energy process in industry. So types of geothermal resources have three types, which is first one is hydrothermal system of naturally occurring water or vapor flow such as hot spring or geyser. Number two, deep aquifer, porous bedrock or fracture zone in which fluids are circulating. Number three is conductive system, like a natural flow of liquid and an artificial injection of water via fracking of the bedrock if necessary. So next is characteristic of geothermal technology. The same with the previous slide, which is number one is hydrothermal system. Direct use geothermal, output temperature is 60 to 180 Celsius, ideal location up to 300 Celsius. Deep aquifer, direct use geothermal, enhanced geothermal, 60 to 180 Celsius, ideal location up to 300 Celsius. So the last, conductive system, enhanced geothermal, shallow, less than 100 Celsius, hot rock 100 to 180 Celsius, and magma more than 180 Celsius. So the next part I will explain about technology of geothermal in the market. So number one is ground source heat pump. A ground source or geo-exchange system consists of a heat pump connected to a series buried pipes. One can install the pipes either in horizontal trenches just below the ground surface or in vertical boreholes that go several hundred feet below ground. For every unit of electricity used in operating the system, the heat pump can deliver as much as 5 times the energy from the ground. Heat pump users should be aware that in the absence of renewable generated electricity to drive the heating or cooling process, that geothermal heat pump system may not be fully fossil fuel free. Okay, so basically this is the heat pump, and this one is a commercial scale ground source heat pump system. This example is demonstrate a project for credit to Craig Miller Production and REL 02409. So next I will explain about how the heat pump works. So they have a two situation, heating mode and cooling mode. Okay, for the heating mode, stage number one is circulation. The above ground heat pump move water or another fluid through a series of buried pipes or the ground loops. So stage number two, heat absorption. As the fluid passes through the ground loop, it absorbs heat from the warmer soil, rock or groundwater around it. So stage number three, heat exchange and use. The heated fluid returns to the building where it used for useful purpose, such as pest or water heating. The system uses a heat exchanger to transfer heat into the building's existing air handling, distribution, and ventilation system, or with the addition of a desuperheater. It can also heat domestic water. So the last stage is recirculation. Once the fluid transfer its heat to the building, it returns at a lower temperature to the ground loop to be heated again. This process is repeated, moving heat from one point to another for the user benefit and comfort. So the next situation is cooling mode. Basically, cooling mode is opposite with the heating mode. So number one is heat exchange and absorption. Water or another fluid absorb heat from the air inside the building through a heat exchanger, which is the way a typical air conditioner works. Number two is circulation. The above ground heat pump move the heated fluid through a series of buried pipes of ground loop. Number three is heat discharge. As the heated fluid passes through the ground loop, it gives off heat to the relatively colder soil, rock or groundwater around it. The last stage is recirculation. Once the fluid transfers its heat to the ground, the fluid returns at a lower temperature to the building, where it absorbs heat again. This process is repeated, moving heat from one point to another for the user benefit and comfort. Technology is pasteurizing milk. Geothermal brine can be used as a heating liquid for pasteurization unit, either by directly use the brine to heat up the raw milk or by heating secondary fresh water. The geothermal brine can be obtained directly from geothermal well or from geothermal power plant separator. Okay, basically this is how geothermal milk pasteurization works. So pasteurization makes sure milk is safe to drink by killing any bacteria and also helps to prolong its shelf life. It involves heating milk to 71.7 Celsius for at least 50 seconds. So geothermal energy can directly power pasteurization plants, making the process more efficient and sustainable. Geothermal also reduce costs. For instance, Oradea milk plant in Romania produce 70,000 litre per day when winter and 200,000 litre per day when summer, for fuel saving of 120,000 per year. So the CO2 reduction, most vegetal and animal meats are pasteurized. Thus, implementing geothermal meat pasteurization will greatly reduce CO2 emission in the agriculture sector. So the third technology of geothermal is energy in aquaculture. The aim of geothermal aquaculture is to heat water to the optimal temperature for a aquatic species. This involves the raising of freshwater or marine organisms in a controlled environment to enhance production rates. This geothermal water is commonly used to heat water in reservoirs, ponds, and tanks. The water temperature depends on the species involved, ranging up to 13 to 30 Celsius. By controlling the rayleigh temperature, the growth rate of the fish can be increased by 50 up to 100%, thus increasing the number of harvests per year. So this figure shows a schematic diagram of the main processes at the Cyprus Fish Farm, Oxford, North Iceland, Jorsan, 2013. So this one is how the geothermal energy in aquaculture. So the last technology is greenhouse. Greenhouses are one of the most prominent uses of geothermal energy in agriculture. These structures protect plants by keeping them at a proper temperature all year, protecting them from harsh, cold and hot weather. Farmers use geothermal energy to heat them and can use geothermal water in the pipes to adjust humidity levels if needed. This power source helps crops grow faster and be more reliable. So this figure show how greenhouse works with geothermal energy. Number one, we can see during the winter months, cold air is pulled from the structure and passes through underground piping where it picks up heat energy. So the next picture is during the summer months, warm air is pulled from the structure and passes through underground piping where it releases heat energy. That's all from me. Thank you.
A very good day to Sir Rosimin and my friends. I'm 2200147 Wong Du Sam, and I'm going to present about the power plant design using renewable energy, which is geothermal energy. Before we get to any calculations, me and my team made a few assumptions for the design, which are seen in this slide. Number one, we assume the mass flow rate of the system is 120 kg per second. Number two, the temperature of the geothermal energy source is at 300 degrees Celsius. Number three, the kinetic energy and the potential energy is negligible. Number four, the pressure at pump inlet is at 10 kilopascal. Number five, the temperature at pump inlet is at 45.81 degrees Celsius. Number 6, the pressure at pump outlet is at 5 megapascal. And the last one, pump and turbine efficiency is at 90% because we are designing an actual power plant. Here is a simple diagram portraying the geothermal power plant. The power plant design consisted of a pump, heat exchanger, turbine, and a cooling tower. The working fluid in this power plant is water. Firstly, cool water is pumped into the heat exchanger. In the heat exchanger, the heat of the geothermal fluid as the energy source from the production well is transferred to the water. This process is called steam recovery. The water then becomes superheated vapor, while the geothermal fluid goes back into the injection well deep beneath the surface of the earth. Secondly, the superheated vapor will drive the turbine at high temperature and pressure, generating power using a generator. In this process, the superheated vapor will return to water mixture state. Lastly, the water is cooled in the cooling tower, producing steam out of the cooling tower. This process is to make sure that the water that goes into the pump is at lower temperature so that the pump will not be broken easily. This process are in a cycle which we call a Rankine cycle. In this diagram, we can see how a Rankine cycle looks like. It represents the process that happens in the power plant. In order to design a power plant in range of 5 kilowatt to 10 megawatt using geothermal energy, Rankine cycle is used because the working fluid of the power plant is water. Water is being heated to a superheated vapor state and drive the turbine to generate power. Rankine cycle operates on liquid that are superheated, which is steam, while the Brayton cycle operates entirely on gas only. In an actual power plant design, the process is irreversible due to the heat loss to surroundings, and hence, efficiencies of the pump and turbine is present.
For the calculation of the power plant design, W net equal to the Q dot in minus Q dot out equal to M dot divide in bracket H3 minus H2A minus in bracket H4A minus H1. Okay, first thing first, we have to find what H1, H2A, H3 and H4A. To find H2A, we can do assumption that temperature at state A equal to 45.81 derajat Celsius and pressure at temperature A equal to 10 kPa. We refer to table A5 and then we can get entropy as 1, and then we refer to table A7. We do the interpolation and then we can get a H2S, which is H2 ideal, and then we find the H2A actual from using pump efficiency, and then we can get H2 actual equal to 197.99 kJ/kg. And then we find H4A. We do assumption T3 equal to 300 Celsius and then P3 equal to 5 MPa. Refer table A6 and then we can get the entropy at state 3, and then we do interpolation using the turbine efficiency, and then we can get H actual at state 4 equal to 2061.84 kJ/kg. And last one, we can get W work net equal to 120 divide 2925.7 minus 197.99 in bracket minus 2061 and 84 minus 191.81 in bracket equal to W net work net equal to 102.93 kilowatt. How to find pump and turbine efficiencies? Pump efficiency equal to ideal pump work divide actual pump work, which is WS divide WA. And for the turbine efficiency, we can find using actual turbine work divide ideal turbine work, which is WA for turbine divide WS for turbine. Improvements. The power plant design can be improved by the following steps. First, increase mass flow rate of water. Second, higher energy temperature of geothermal source. And the last one is add regenerative process, which is reheating.
Assalamualaikum warahmatullahi wabarakatuh. My name is Siti Nurul Fatihah binti Khalid, 2200191, and I want to talk about potential of renewable energy, which is geothermal energy in Malaysia. So there are 5 renewable energy in Malaysia, which is biomass, biogas, geothermal, hydro power and solar. So there are 3 places which has potential for geothermal energy. The first one is current potential for geothermal energy is in Apas Kiri, Tawau, which is in Sabah, with potential resource of 85 megawatts. Second one is in Ulu Slim, Perak, which is in Peninsula Malaysia, with potential resource of 148 megawatts. And the last one is in Sungai Jipun, Tawau, Sabah, with potential resource of 40.28 megawatts. So next I want to talk about the advantages of geothermal energy in Malaysia. The first one is silent energy. Geothermal power plants produce negligible and imperceptible noise levels during the construction of the plants, including excavation. A certain amount of noise is inevitable, but once construction is complete, everything is silent. The second one is geothermal energy always available. Aside from being essentially unlimited like many other renewables, geothermal energy is always available. On average, a geothermal power plant will produce energy for around 8,600 hours per year. When in solar plant, the average is around 2,000 hours per year, which is geothermal is higher than solar plants. Next one is allows double recycling. Geothermal power optimizes resources. On the one hand, the plants have components that can be salvaged and reused at the end of the installation life cycle. On the other, during operation, the flows are organized in such a way as to put any heat that cannot be used immediately back into the circuit using the steam pipes that power the plant, helping to save energy. Then, the next point is the Earth's heat can also cool. When geothermal energy is mentioned, we think first and foremost of thermal energy and heating. Geothermal plants are designed to both heat and cool. This is why, aside from the large station, geothermal power system can be installed in almost any type of building, from homes to shopping malls, public buildings, and sports centers. And the last point is geothermal energy requires very little maintenance. Particularly when it comes to domestic use, geothermal plants do not require any special maintenance. As they are closed system, the pressure of the fluid in the piping self-regulates, and the number of electrical and mechanical elements that can break down is also very small. So that is all advantages from the geothermal energy. That is all from our group. Thank you for your attention and have a good day.